Alright, hello everybody, welcome back. We are, in this video, we're working on dilations. We are going to do one example where we're going to do an enlargement. That means it's going to get bigger. And then we're going to do a reduction, and that means the image will become smaller. Starting with the enlargement, for a dilation, you need to know what the scale factor is going to be, and you need to know what the center of dilation is. In this case, our center of dilation will be the origin. For this problem, which is an enlargement, our scale factor is 2. That basically means it's going to multiply by 2. We are going to use the variable k in our rule to represent the scale factor. All right. And basically, for dilations, you multiply it, and if the center of dilation is at the origin, you will simply multiply the scale factor to each coordinate. So that means k will be multiplied to the x, where k is the scale factor, and then k will also be multiplied to the y. Your result from this will be your image after a dilation. So when we look at this problem, if point A is negative 2, 3, A prime is going to be calculated by the scale factor, which is 2, times the negative 2 for your x value, and the 2, again, which is the scale factor, multiplied to the 3. Your result is your new coordinates for A prime. 2 times negative 2 is negative 4, and 2 times 3 is 6. And you'll do the same for each point of the figure, or each vertex of the figure. So B prime, 2 times negative 1, and 2 times negative 2. So B prime becomes negative 2, negative 4. C prime, 2 times 2, and for the y value, 2 times 3. Therefore, C prime equals 4, 6. When you graph this, you should notice that the image enlarges. It gets bigger. All right, so let's go down here. So A prime is negative 4, 6, negative 4, positive 6. 1, 2, 3, 4, 5, and 6. There's A prime. B prime is negative 2, negative 4, negative 2, 1, 2, negative 4, I'm sorry. 1, 2, 3, 4. There's B prime. And C prime. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. C prime. All right, let's connect. Don't let this fool you. I'm using a marker so that line is slightly to the right of that original line. All right, our next example is a reduction. So we're using the same figure. The scale factor is 1/2. So that's a big thing to notice. If it is an enlargement, your scale factor is a whole number. If it is a reduction, your scale factor will be a fraction. All right. You're going the same thing. You're going to multiply the scale factor to each coordinate. You're going to multiply the scale factor to each coordinate. So for the reduction, let's go down here. Remember, our scale factor is 1/2, or 1/2. So for A prime, 1/2 times -8, 1/2 times -9. And that equals, with A prime, 1/2 times -8, basically half of -8 is -4. And then 1/2 times -9, half of -9 is -4.5. Off my paper here. So A prime is -4, -4.5. B prime, 1/2 times -5, and 1/2 times 2. B prime, half of -5 is -2.5, and half of 2 is 1. For C prime, 1/2 times -1, and 1/2 again times -1. So when we reduce that, half of -1 will be -1/2, or -0.5. Half of -1 is 0.5, or -1/2. All right, now that we got our coordinates, we can go ahead and graph. A prime is -4, -4.5. 1, 2, 3, 4. We've got to go a little bit more. So there it is. There's A prime. You notice that in the reduction, it gets closer to the origin. Where here in the enlargement, it goes further away from the origin. B prime, -2.5, +1. So right there, there's B prime. And C prime, -0.5, -0.5. So it's right there, C prime. That's a hard one to see. All right, we're going to connect them together. That's it. That's the reduction. Remember, for dilations, with the center of dilation being the origin, you simply multiply the scale factor to each coordinate to get your prime values. Thank you for watching.